Introductions to Solutions and Aqueous Reactions, Solution Dilution. In this tutorial, we'll be looking at solution dilution and some worked examples. Solution dilution is a process where solutions of higher concentrations, which means higher molarities, are changed into solutions of lower concentrations by adding the solvent water. When solvent is added to dilute a solution, the number of moles of solute in the solution remains unchanged. And this is an important point. So I gave us this little visual down below. Let's say we're staring down into a beaker. So we have solutions of 1 molar, 0.8, 0.6, 0.4, and 0.2. What you should notice here is that the moles of solute in each one of these is exactly the same. Moles of solute are the same, but the volume of the solution as a whole, solute and solvent, gradually increases over time. So we go from 1 liter to 1.25 to 1.67, 2.5, and 5. And what we notice is the change in color as we go through the solutions as the concentration lowers. Now, it is my hope that in your lab section of this course, whether online or in person, you have the opportunity to go through the process of making a solution and going through the solution dilution process over time, but that's a video for another time. Let's look at some solution dilution problems. Calculate the volume of a 0.480 molar sulfuric acid that must be diluted with water to produce 12 liters of 0.0720 molar sulfuric acid. Okay, so let's always start off by writing the dilution formula, which is M1V1 is equal to M2V2. So we have our initial molarity, which will always be a higher molarity, our initial volume, then the molarity that we are targeting to achieve, and the volume associated with that. So if we look at our problem again, calculate the volume of 0.480 molar sulfuric acid. Okay, the volume is what we are looking for. So that is going to be technically our X. That's what we're going to solve for. This out of our two concentrations, because it says must be diluted with water to produce, hey, we're trying to get to 12 liters. So that is going to be our V2. That's the total volume that we want to end up with. And this 0.0720 is the molarity that we want our solution to ultimately be. So this first molarity right here has to be the molarity that we're starting out with. So this is our M1. So what we're going to do is we're going to plug all of our known and unknown variables into our formula. So M1 is going to be 0.480 molar. Our V1 is what we are starting with. So what's our initial volume going to have to be? Our molarity 2, M2, is what we want to end up with. So 0.720. And then V2 is our total volume at the end. So 12 liters. All right, so then if we go through all of this and we divide both sides by 0.480, our V1 ends up being 1.80 liters. And that is following our significant figures. If I go back and I look at all my original numbers, 3 sig figs, 3, and 3, so we're all good there. Now, what does this V1 really mean? Okay, so this V1 is the amount of acid. So I'm just going to put amount of acid that we need to add to the water that we're adding into the solution. So of course, using proper techniques to dilute a solution when adding acid, we'd add a total of 1.80 liters of acid. Now, ultimately, we need to get to 12 liters. That's our final amount of this lower molarity acid that we want. So we'd say, all right, well, how much water do I need to add? So it's a total of 12 liters. We have 1.80 liters of acid. So this is the acid amount that I need to add. This is my total volume that I want to achieve, which means if I subtract these two, I need 10 20.2 liters of water added to overall. So this is the amount of solvent that ultimately will be added to this to get to 12 liters of a molarity of 0.072 molarity of my sulfuric acid. Let's look at another example. Okay, in this example, we're going to determine the volume of a 12 molar hydrochloric acid stock solution required to make 50 milliliters of a 0.5 molar hydrochloric acid solution. So again, we're looking for our initial volume. We're looking for V1. This is our M1 because it is our higher concentration. We're only looking to make a small amount. So this is our V2 and our M2 because we want to dilute it down to 5 molar. So I'm going to say M1 V1 is equal to M2 V2. Going to plug in what I know, which is my molarity is 12 molar. Again, I'm going to be looking for my V1. So what is the amount of acid that I need to add? Because we're going to add acid to our water in the correct, proper way of making dilution. And we're trying to get this down to 5 molar. And we want 50 milliliters of it. And I'm just going to leave it as milliliters. As long as I'm consistent, I should be fine. It's not like I'm trying to solve for moles or anything here. I'm just doing a dilution problem, so I'm okay with leaving this in milliliters because it's such a small amount. So if I work through this whole thing, my V1, the volume of the 12 molar acid that I need, is 20.83 repeating milliliters. So let's say for the sake of significant figures that I need 20.8 milliliters just to keep it simple. So, okay, so I need 20.8. My total volume here is 50 milliliters. That's, again, we're just going to put total volume. And then I'm going to subtract 20.8 from that original amount. So if I subtract those two, I get 29.2 milliliters. So that is the amount of water that I need. Amount of H2O. So again, when you're doing these types of problems, you need to think about your formula. You need to write everything out. You need to identify what variable you are solving for. Pay attention to your significant figures and understand what you're solving for. V1 isn't just a final amount, it's the amount of acid, but then you need to really go back and think about what is the problem asking? Is it looking for the volume of acid that we need to use for the dilution? Are you looking for the amount of solvent that you need to add to the solution to dilute it down? Just be really, really careful about what the problem is asking you to do. So what did you learn in this brief tutorial? We went through the definition of a solution dilution, and then we looked at some worked examples. Need more help? Feel free to contact me. Have a great day.